Hello everyone, welcome to the platform of Unacademy, India's largest online learning platform where you are preparing for your aspired examinations, that is the GATE and the ESE. So, before starting the lecture, let me give a brief introduction about myself. My name is Vidyapati Kumar and I have a 4+ year of teaching as well as research and development experience. I have done ME from Jadavpur University and my specialization was production. I have worked at CSIR, Central Institute of Mining and Fuel Research. I have also qualified GATE twice, and I'm the author and co-author of various research papers publication of National and International Journal of Review. You can follow me here at unacademy.com at the rate of v.ksir. You can follow me here as I am teaching a lot of subjects there. So definitely by following me there, you would be getting notified about the topics, about the subjects, about the courses that I would be taking in the future. So in this particular session, we are going to discuss about the machine tools and our focus would be more specific towards the gate. So I would be discussing the machine tools, and that is the lathe, which is totally focused from the gate point of view, because there are a lot of areas from where the questions from the lathe can be framed, and the IIT Bombay, which is the organizing member of this gate paper. So basically in that there would be a chances of the questions that may be coming from the machine tools. So this session would be purely based upon the gate. Bilbo ji, see here, there is a batch which is gate preparation for 90 days. I would be discussing that. Okay, so there is a batch which is gate preparation 90 days, which has already been started in October and the first month of November. Clear? So definitely you can enroll in these batches, and it is very good. It is very good because your all the preparations would be in the 90 days itself. Okay, there are a lot of benefits in that batches. Top educators are already teaching there, and whenever you are enrolling in these batches, use my code SIRVK SIRVK to get the maximum discounts. Okay, so let's start our discussions. If you have not downloaded the Unacademy Learning app, download the Unacademy Learning app, where there is a special class which I regularly take, this special class which is totally free. And in that special class, I have totally covered the strength of material full course. Okay, so tomorrow I will be giving you the practice questions. Okay, so there would be a lot of practice questions for strength of materials. So do watch my tomorrow's session, that will be happening on 10 a.m. Okay, and this is totally free. Good evening, Ashish ji. Good evening. Can we access the October lecture? Yes, definitely Bilbo ji, definitely. Just आप मेरे साथ just 2-3 मिनट बने रहें, मैं आपको पूरे अच्छे से समझाऊंगा कौन कौन से बैचेस हैं और उस बैचेस में आपको कितने फायदे मिलेंगे. ठीक है. नमस्ते सत्यप्रकाश जी, नमस्ते. चलिए, so if you have not subscribed the plus subscription, sir, then do it, as it is totally worth it. Entire syllabus would be covered, and the benefit is that you are getting the doubt clearing sessions are also there, daily live classes are there, so you can interact with your educator. Suppose I'm your educator and you can interact with me. If you have any kind of doubt at any point of time, you can call me, you can WhatsApp me, you can contact me. At the same time, you can also raise the issues when I'm teaching. So that is the best thing in the live classes. Structured courses are there, that is properly framed in a very strategic manner. Tests and quizzes are there, and the unlimited access of the content materials are there. If you are going for the iconic subscription, basically the benefit is that one subscription give you the access of both the exams, that is for the GATE and for the ESE. So you are getting all the benefits of the plus in this iconic. Apart from that, extra benefits that you are getting is personal coach. That personal coach is liable to help you throughout the preparation of GATE and ESE. That will help you, mentor you at each and every point of time where you actually requires the need. Because at some point of time there is a helping hand that is very much required, that what should be my strategy, sir? I have studied 80% of the syllabus has been covered by me. I have prepared these things, that thing, I have prepared formula sheet, I have done n number of ways to increase my numbers, but even if my numbers are not increasing in a very good manner, what should be done? So definitely personal coach has a very significant role in there, that will monitor you, that will help you, that will mentor you, as well as that will also monitor your test, whatever the test, mock test, practice test, whichever you are doing. So that test would be properly analyzed, and the weakness and a strong point would be let you know. As well as you can also work out on these things. So study planner would be given to you, what should be your study. So study को आप कैसे plan कर सकते हैं जिसके कारण आपका बहुत अच्छा marks आए. Preparatory study materials would be given to you, such as the PDFs and the other content materials. So these are the benefits, extra benefits that you are getting in this Iconic subscription. Definitely you can go for the Iconic or for the Plus subscription, and any of the subscription, and any of the subscription would give me will give you the access of to study from any of the educators. Okay, Jaspreet ji, see, if any point of time, if the Unacademy team feels that you are violating the rules and regulations, then they are blocking the people. Otherwise, in the normal case, nobody blocks no one. Okay. Okay, see here, for the GATE and the ESE, there are a lot of batches which has already been started. You can go and check out these batches. If you, for example, for the mechanical, civil, for the production industrial, there are a lot of batches which has already been started. As Bilbo was telling that what are the batches which is best. So for the mechanical, these batches are there. For the ESE, and there are a lot of batches for electrical branch, for the ECE branch also. So definitely you can check out these batches. And this batch, GATE preparation 90 days, which has already been started in 2nd November, and definitely you can go and enroll in this batch if you really want, and use my code SIRVK, SIRVK, for the maximum discount. As well as you will getting the benefit as you are enrolling with my code. So definitely I will provide my personal mentorship to you at the same time. So this is a benefit which is if you are enrolling with my code. And these are the courses, that is rapid revision batches. Suppose that your preparation is very good, you want a quick revise. If you want a very quick revise, then these batches are very good. And one more batches are there, doubt clearing batches are there also. So in that, only doubts would be taken into the consideration. As well as, suppose that if you have given a GATE twice and a thrice, and definitely you are not getting a very good rank, so rank improvement batches are also there. Because at that point of time you are well aware about the syllabus. Because first time when the people are giving the exam, they are not well aware about the syllabus, where they are not well about the curriculums, how the questions are framing, how the different IITs are actually setting, will give the focus on the different subjects. So basically these things are very much unknown if you are giving the examination for the first time. So that is the thing that is very much important. So based upon that, you can go and check out these batches if you really want to enroll in these batches. And if you want to go for the Plus subscription, these are the prices. Suppose that if you want to go for the Plus subscription, if you are preparing for the GATE 2021, you can go for this 1-month plan and for a 3-month plan. And if you are in a second or in a third year, definitely you can go for these plans. And do not forget to use my code SIRVK, SIRVK, to get a 10% off, as well as to get my personal mentorship. Suppose that if you're going for a 12 months plan, that will be costing around 30,250, and the discounted amount would be 27,225 if you are using my code SIRVK. As well as, if you are going for the Iconic subscription, again use my code SIRVK, SIRVK, to get the maximum discount. And also one more thing that I would like to tell you, that tomorrow I will be taking a section of practice session for strength of materials, which is very much important for GATE point of view. You can watch my videos at 10 a.m. as well as you can follow me here v.kesar for in the Unacademy app. So let's start our discussions of the today's session, that is the machine tools, which is totally focused for GATE. Okay. Okay, so what I will tell you, Jaspreet ji, mail me at this address. You can mail me here, and at that point of time I would clarify your doubts. Okay, because this is totally the class which is for everyone, and I cannot share these kind of things here because everyone will be getting disturbed. So you can contact me there and I would definitely help you. That is for Jaspreet ji. And yes, yes, Bilboji, definitely, definitely. You can see, you can attend a lot of things. That is what is the benefit here. That is what is the benefit here. So, in the plus subscription, basically, if you're going for the plus subscription, definitely GATE as well as the ESE, है ना? GATE की जितनी भी materials होंगी और ESE की जितनी भी materials होंगी, वो सारा आप access कर सकेंगे, और iconic में different treatment होता है, ठीक है? Okay, so let's start our discussions for the today's session. Please see here, my dear friend. Again, I'm going to tell you that I'm not going into very great details in the lathe and the lathe operations as well. No, I'm not going into that. But what I'm discussing in this particular session is that what are the areas from where the questions may become in the GATE 2021, and that area will be discussed by me. Okay. Okay, see here, basically this is a lathe. Okay, this is a lathe, and before going into the lathe, you should always keep in mind what is the meaning of the machine tools. Basically, the machine tools includes the lathe, the drilling, milling, grinding. A lot of machine tools are there, and the main purpose of these machine tools is to remove the material, and more importantly, the material is removed. Suppose this is the workpiece, this is a tool, so there is a proper contact between the tool and the workpiece. So that is known as conventional machining, that is known as traditional machining, because we have seen the non-traditional machining in which there is no contact between the tool and the workpiece and the machining is performed. So basically, in this session, machine tools is required to do the machining operations, and the first machine tools is lathe. So lathe you have seen in your workshop. Definitely this is not the new to you, and just I am here to get the revise the everything that you have studied till now. So basically this last end, which is known as tailstock. Okay, this end is known as tailstock, this is known as headstock. Fine. Now see here, this is the chuck, this is the chuck which is rotating, clear. And there is a this is the lead screw. So this is the lead screw, in which the main function of this lead screw is that whatever the rotary motions that you are giving to this lead screw, that rotary motion is converted into the linear movement. Fine. And that is why lead screw is used in the lathe to machine the workpiece. Fine. Based upon that, let's start our discussions. What are the operations that we perform in the lathe? So the first operations that we perform is known as facing. And what we do in the facing, basically there is a shaft. So suppose this is your shaft, and the shaft is fixed in a chuck. Okay, so suppose this is your chuck, and this chuck is in this chuck, this shaft is fixed, and This is your tool. This is your tool. So when the tool movement is in this direction, when the tool movement is in this direction, then you can understand that this much amount of part will be reduced. Okay, when the tool is moving in this direction, then what will happen? This much amount will be reduced. Now if this much amount is reduced, you can very well understand that the length earlier, the length of the shaft was this. Suppose the L is the length of the shaft. Due to the facing operation, there is a reduction in the length. Clear? So that is always keep in mind. With the facing operation, reduction in length is occurring. Next operation is there, that is known as turning operation. Turning operation. Now, how you can say that it is a turning operation? I'm pretty much sure that you all have worked in the lathe and done these kind of operations. So this is just a preliminary things that is helpful for you to get the revised the things. So suppose again this is the shaft and this is the chuck. Fine. Now what is happening? This is the central axis and this is rotating. Fine. One more important thing, that this is rotating like this. Clear? This is rotating. Okay, this is rotating. Now what is happening? Now what is happening? In place of moving the tool in this direction, you are moving the tool like this, in this direction. Now try to think about it, that this shaft is rotating, the shaft is rotating and your tool movement is in this direction. That simply means there would be a reduction, something like this. There would be a reduction, something like this. Because it is rotating, so definitely reduction would be something like this on both the sides. On both the sides. Now what you can understand from this figure is that this much material is removed, isn't it? This much amount of material is removed. Now this much amount of material is removed, that simply means that earlier it was having the diameter of D, now it is having something like this is the diameter. So this simply means that there is a reduction in diameter. Now it is worth needed. No, Ranaji, no. This is what is happening. In facing, basically you are moving the tool in the this direction, and in this turning operation you are moving the tool in this direction. Fine. And due to this, there is a reduction in length in this first case, and in the turning operation, this is what is happening. Now it is worth understanding that turning operation is actually performed when you want to make a taper shape. Suppose what I want to say from it, that is known as taper turning. Or before going into taper turning, let's try to analyze what is happening in actual case of a turning operation. Fine. So suppose this is your turning operation. Suppose this is your turning operation. And what is happening? Suppose this is your shaft like this. And what you have done, you have turned this shaft something like this. Try to think about it, that earlier the shaft is unmachined, that is not machined, and something like that was the shape. Now when you have fixed this shaft, on a chuck, and this is rotated, this is rotated. When this is rotated, And when this is rotated, what is happening? The turning operation is performed. Suppose something like this is a tool. Okay, something like this is a tool. What you have seen here, this kind of tool was there. So suppose this is the tool which is moving. Clear? Which is moving in this direction. Now you can very well understand what is this. This distance is known as small d, which is known as depth of cut. By how much amount of the depth you are cutting the machine element part, and that is known as depth of cut. So basically this is known as d is depth of cut. Now try to understand that earlier case. Suppose this is the d1, this is the d1 diameter is there, d1 diameter is there, and after the machining operation you have converted this into something like this. So this would be your d1, this diameter would be your d1, and this diameter would be your d2. Okay, now if I would be asking you, can you tell me what would be the value of depth of cut? See here, basically the depth of cut would be, this will also be the depth of cut. Can you say from the geometry what will be the depth of cut? Can you say anything about the depth of cut? What will be the magnitude of depth of cut? Pratyush ji, I cannot understand your question. d1 minus d2 by 2. Very good, very good, very good. So Asis has also given, Rana ji has also given. Very good, both of you, very good attempt. Now try to understand your depth of cut, that is d will be something is equal to d1 minus d2 by 2. Now if I would be talking about the average diameter, see earlier d1 was the diameter, and now after the turning operation has been performed, d2 is the final diameter. So if I would be talking about the average diameter which is denoted by d average will be given by d1 plus d2 by 2. Now you may be asking, what is there is a need, why there is a need of calculating the average diameter, sir? Don't worry, my dear friend, just stick with 5 minutes, and after that this answer will be coming to you. Okay, don't worry about the answer. Now if I would be asking to you, if you are making a, suppose this is a side view, if you are drawing a side view, then what is the situation, what is the scenario that you are getting? See here, from the side view you can get your answer. See, this much amount is the earlier case, so this was the earlier unmachined part, and this is now the thing, this part. Now see here, when you are machining, after the machining you have removed this part, isn't it? You have removed this part, ठीक है, आपने इस पार्ट को रिमूव किया है. Now what you can say, this is your d2, this is your d2, this is your d2, this is your d1. Clear? This is your d1, and this is the amount which is removed, so this part is cut, this part is cut. Now if I would be asking you, can you say what will be the MRR, material removal rate? What will be the material removal rate? And here, if you have not watched my lectures which I have already given for the machining operation, you can, in this video itself you can see there is a playlist. So go in that playlist after the ending of this lecture. Go into that playlist, watch my all the videos to get the proper knowledge of everything. Okay, so I have already completed the machining part. This is just a machine tools part which was not covered, which is I am taking here. So what will be the MRR, material removal rate? What will be the MRR? So MRR will be volume which is cut by time, isn't it? And this can be written as area under velocity, which is feed velocity. Why the feed velocity? Because you are giving the feed, है ना, आप feed दे रहे हैं. So now this is the MRR that you are getting. So can you say what will be the area in this case? The area that is machined is pi by 4 d1 square minus pi by 4 d2 square. This is the area which is machined. So if I would be writing here MRR, the area will be coming to be area into feed velocity. So the area in this case is pi by 4 d1 square minus pi by 4 d2 square. Yes, definitely, Parmarji, definitely that is the thing, and that is what I have written here. Okay. So see here, this is the area, and what is the feed velocity? Basically, feed velocity is denoted by VF, and that is given by F into N, where F is the feed, and its unit is mm per revolution. N is the rotational speed, and that is given by revolution per second is the unit. Fine. Now from here, what you can write further? So this is your MRR that you have got. Let's try to rearrange the things that we have got. Can we write like that? Pi by 4 d1 minus d2 into d1 plus of d2 into F into N. Let us rearrange one more times. Then you would be getting pi d1 minus d2 by 2 into d1 plus d2 by 2 into F into N. This is your MRR. Now, my dear friend, do you remember something which we have discussed just starting of these things? That is depth of cut, which is given by d1 minus d2 by 2, and the average diameter, which is given by d1 plus d2 by 2, isn't it? So can we replace here as MRR would be coming to be pi. This d1 minus d2 by 2 will be the depth of cut. This d1 plus d2 by 2 will be the d average, and this will be your velocity. Is there any doubt in understanding these things? Do you have any doubt in understanding these things? Just let me know. Because this is the very important formula that is in front of you. That is, from this formula, a lot of questions may be asked in the GATE. है ना? Pi, where this is your velocity, this is your feed velocity, Okay. Now try to understand that. Okay, so right now we are in a position to find the material removal rate in case of a turning operation. Now, but in reality, what is happening? See here, that suppose this is your, suppose this is the part that you are machining. Okay, ये part आप machine कर रहे हैं. अभी देखिए, आपका टूल जो होता है ना, योर टूल never be in this initially. See, my dear friend, again, if you want to machine these kind of thing, your tool will never be at this part. ठीक है, यहां पर टूल नहीं रह सकता है, टूल मे बी देयर, अगर वहां पे रहता है अच्छी बात है, बट इन जनरल टेक assumption what we are taking here that suppose the tool is somewhat here, है ना, क्योंकि ये जनरलाइज्ड assumption हो जाएगा फिर हमारे लिए, एंड फॉर दैट वी कैन derive the things. Suppose that tool is something at here, clear, something like that. So tool, initially tool is present at this part. So basically tool will have to travel this much distance, which is known as approach distance. I repeat, this distance is known as approach distance, which is noted by A. Now see here, let us suppose this length is L. This length is L. Clear? Where A is the approach distance, and this tool is moving in this direction with some velocity, that is the Vf, that is the feed velocity. Now I may be asking from you, my dear friend, suppose that this tool is moving in this direction and this much amount of distance it has to cover, that is the A plus L. So can you say what will be the time required to machine this component? What will be the time required to machine this component? See here, my dear friend, initially you were having something like that. Initially you were having something like that. ठीक है, कुछ इस तरह का था आपका, यहां पर आपका टूल था, ठीक है, from here that your tool is moving and basically you want to get something like this. Then can you find the time required during this machining operation? Can you tell me anything about the time required? I'm waiting for your reply. Whether you are giving a correct reply or a wrong answer, that is none of the concern. But participating in these questions is very much important, so that if you are doing some kind of error, you will be understanding what exactly was my error. Do you have any idea? Okay, see here, basically the time will be given by, this time will be given by distance by velocity, isn't it? That is L plus A by Vf. Any doubt? Any doubt? Yes, yes, yes. See, total distance कितना move करना पड़ रहा है? How much distance this tool has to move? That is the approach distance and the L distance. So basically this is the total distance and it is moving by the velocity Vf in this direction, and this is the speed, that is the Vf, and hence you can find this time required during the machining by this particular equations. So that is what is happening in this turning operation. That is what is happening in this turning operation. Okay, now let us try to understand the next thing that is happening, that is known as taper turning. So I assume that up to this part no confusion would be there and you are in a very good conditions to understand each and every things. Now try to understand that sometimes we require to make these kind of structures and these kind of shapes that we want to make. Suppose this is the workpiece, something like that is the workpiece, and you want to do a taper turning which is like this, which is like this. You want to do a taper turning based upon the necessity, based upon the requirement, you want to do a taper turning. So basically what you can understand here कि ये जो जगह है ना, ये जगह इतनी दूरी में आपने टैपर टर्निंग को किया है, right? So you have done the taper turning. Now the question that may be coming into the mind, sir, you have told that this is what is being done in the taper turning, but how shall we achieve the taper turning? Because we have seen that कि सर टूल तो हमारा ऐसा होता है, अगर टूल ऐसा हो गया और इसी टूल को मैं अगर इस तरफ मूव करता हूं तो टैपर कैसे होगा? टैपर तो बनेगा नहीं. सो फॉर दैट कंडीशन माय डियर फ्रेंड, बेसिकली द थ्री मेथड्स आर यूज्ड. First method is by using the form tool. Using form tool, that is form tool. What is the meaning of form tool, my dear friend? Basically the form tool is something like this. Basically the form tool is something like this. ठीक है, ये कुछ टूल इसी तरह का होता ही है, और आप इस टूल को इस डायरेक्शन में मूव करते हैं और आपका टैपर टर्निंग बन जाता है. Else what you can do, my dear friend, next thing is by using the combined slide method. So by using the combined slide, how we can use the combined slide? If you could go into the very first picture here. So basically this is the compound rest, this is the compound rest, and this is a cross slide. So basically at this you can see here that combined slide is there, and that slide is actually moved in this direction. So basically see, this is suppose this is the workpiece that is being held here. See here, this is the workpiece, and on this workpiece you have made a turning operation, that is the tapper turning. Clear? That is the tapper turning. And what you have done, so this is basically your combined slide, this is your basically the combined slide, and this is the axis, this is the axis. So you have given, you have just given some angle to this slide. Suppose this angle is, angle is given by alpha by 2. Okay, and you are making the tapper turning. So this is the one method by which you can make the tapper turning. Don't go into very great details because ultimately the questions will be asked from this. So this is how you can achieve the tapper turning. Next method is this. Next method is this, that by offsetting the tailstock. So basically see, this is your live center or known as the headstock, or this is your dead center which is known as the tailstock. So basically if you could see in this figure, सी बेसिकली दिस इज द टेल स्टॉक, है ना, ये जो होता है ना आपका, ये टेल स्टॉक का पार्ट होता है, और एकदम इसको बोलते हैं हम लोग डेड सेंटर. ठीक है, तो अभी क्या करते हैं हम, व्हाट एग्जैक्टली वी आर डूइंग हियर, try to understand that earlier this is the configuration of the dead center. Now what you are doing, you are offsetting this dead center, means you are giving some offset. Suppose this offset is given by y, this offset is given by y. तो आप क्या कर रहे हैं, you are giving some kind of offset, and by giving some offset which is known as offsetting the tailstock. So by offsetting the tailstock, again you are achieving the tapper turning. Fine. Now try to understand that in this combined slide method, what is happening. In this combined slide method, what is happening? See here, my dear friend. Basically, you are making something like this. You are making a tapper product by a tapper turning operation. Clear? So this is what is the thing. Now what is this? Let us assume this to be your D1, this diameter to be your D1, and this diameter to be your D2. D1 and D2. Now there is an angle which is made here. Let this angle be as alpha by 2. And what is this alpha by 2, my dear friend? This alpha by 2 is actually half tapper angle. Because see, basically this will be making something like this alpha. So I am taking only the half part, that is the alpha by 2. So you should not confuse this alpha by the rake angle. You should not confuse this alpha by the rake angle. Okay, so this here the alpha by 2 is the half tapper angle. Now from here, from the geometry, you can say that if this length is L, if this much length is L, then you can get that alpha by 2 is equal to tan inverse of D1 minus of D2 by 2L. Clear? And from here alpha will be 2 tan inverse D1 minus D2 by twice of L. So this is what is the angle. So in the gate, the questions that are asked, that what should be the angle, what should be the angle, this angle should be what, ये taper angle कितना होना चाहिए, what should be the taper angle in order to do the taper turning. ठीक है, अगर मैं if I am using the combined slide method, then what should be the value of taper angle in order to form the taper turning operations. ठीक है, तो ये क्वेश्चंस पूछा जाता है. ओके, सो आई होप you have got a very good idea in that, और आपको कोई confusion नहीं होगा. Even if you have any kind of confusion, then you can also leave the message and then I would take your doubts. No problem. Okay, do you have any doubt or not? Just let me know. Just let me know. Okay, so I assume that each and everything is clear to you. Each and everything is clear to you. So let's try to understand more things. This is your tail stock offset method. And what is basically the difference between the tail stock offset method and the compound slide method? You can see here, basically you are giving some rotation, you are giving some taper angle to the compound slide itself, isn't it? But here in this case you are offsetting मतलब कि अगर ये आपका डेड सेंटर था तो आपने डेड सेंटर को कुछ ऊपर के तरफ में रख दिया. That is known as offset, giving some kind of offset. So that is the offset. So basically in that, dead center has been given some kind of offset, है ना? This was your initial position and this is your final position, and this is the offset that you are getting. Clear? Now basically in this method, tail stock is placed at an axis from the central lathe axis. See here, suppose this is your central lathe axis, clear? This is your central lathe axis, and in this method, tail stock, so earlier this was the tail stock, so tail stock is placed at an axis from the central lathe axis, such that the offset angle is half the taper angle. So basically this angle is given by alpha by 2. So again I repeat, what is the alpha by 2, my dear friend? Alpha by 2 is your half taper angle. Do not confuse this taper angle with the rake angle. I repeat, okay? Don't confuse. Now see here, you can understand that in this figure, let me draw the figures also so that you can get, now this figure is clear to you, right? This figure is clear to you. Now try to understand that, suppose my dear friend, that this is your workpiece, okay? And on this workpiece, this is your axis. Try to understand, this is your central lathe axis, okay? This is your central lathe axis, and earlier, so suppose that, see here, just a minute, let us assume this to be your lathe axis, okay? This to be your lathe axis, and try to understand that here you are giving the tail stock. So here is your tail stock. Just try to understand, okay? Just try to understand, nothing big is there in this. You would be getting each and everything. ठीक है, ये tail stock है. Suppose this is your tail stock, and my dear friend, this is what is your offset, isn't it? यही तो आपका offset होगा ना. This will be your offset. And see, my dear friend, this, suppose this is your A and this is your B. So what is this A and B? Can I write this A and B? This AB will be the length of workpiece, isn't it? So let me denote this length of the workpiece by L of W. So let this be L of W. And what will be this length? This angle is given by alpha by 2. Just now we have seen, my dear friend. Now from the geometry, you can very well say that sine of alpha by 2 is equal to y by LW, where LW is the length of the workpiece. Now from this particular formula, you can find that what will be the offset will be given by LW sine of alpha by 2. I repeat once again, I am repeating here, I am writing here, so that there should be no confusion in that, where y is your tailstock offset, alpha is your half हाफ टैपर एंगल। ठीक है, तो अगर क्वेश्चन में आपसे टैपर एंगल पूछा है, माय डियर फ्रेंड, आई रिपीट, अगर आपसे क्वेश्चन में टैपर एंगल पूछा है, दैट मींस दे आर इंटरेस्टेड इन अल्फा, दे आर नॉट इंटरेस्टेड इन अल्फा बाय 2। ओके, सो दैट इज व्हाई आई एम राइटिंग अल्फा बाय 2 इज द हाफ टैपर एंगल। क्लियर? सो आई होप दीज थिंग्स आर क्लियर टू यू, कोई डाउट नहीं होगा। चलिए एक और फिगर हम देख लेते हैं जिसमें आपको और भी ज्यादा अच्छे समझ में आ जाएगा चीज क्या हो रहा है। See here, basically this is suppose, so see here, earlier in that case I have drawn something like this figure, right? Something like this figure, right? So I am drawing the same figure here to get the better understanding of the concept. See here, try to understand that this is what is the taper turning happening. Okay, this is the taper turning, this is the taper turning, and basically in this part what is happening, this much part is this much, at this much part only the taper turning has been done. ठीक है, ये जो है, let us assume this part to be small l, let us assume this part to be small l, and the entire length of the workpiece, the entire length of the workpiece is denoted by the L. Clear? Denoted by the L. Now if I would be asking you what is the tail stock offset, so you have just found out that tail stock offset is this, sir. ठीक है, अभी यहां पर एक टर्मिनोलॉजी यहां पर आप याद कर लें, जिसको कहते हैं सेट ओवर, which is nothing but this is also known as tail stock offset, which is given by capital L by small l into capital D. Let us assume this to be D1, this to be D2, so D1 minus of D2 by 2. Now why I am writing this equation? Because see my dear friend, you in some of the cases, maybe in some of the cases, suppose that these lengths are given to you and the diameters are given to you, so somehow in that case, to save your time, because ultimately you have to calculate the alpha, so if you are going to calculate the alpha, then obviously your time will be killed. So how you can calculate the alpha? Basically the alpha that will be calculated, that will be tan alpha by 2 is given by, see, basically this is the alpha by 2, this is the alpha by 2, है ना? Same thing that we have seen, tan alpha by 2 will be given by capital D1 minus D2 by 2 into 1 by L. This is the alpha by 2. So try to understand कि पहले आपने अल्फा निकाला, फिर अल्फा निकाल करके फिर आपने लेंथ ऑफ द वर्कपीस से मल्टीप्लाई किया, so that may be something two formulas that you have to use, and in that some of the time is very much important, so to save the time, always remember these things. So that is what is for entire thing for the set over. So set over or the tail stock can be found by this formula, tan alpha by 2, that is the half taper angle, by this formula, and again this is the tail stock offset, which can be found by this formula. So I hope tail stock offset method to form the taper turning is clear to you. Let me take your comments if you have any kind of doubts. Thank you, Deepak ji. IS MQC के लिए कौन सा बुक रेफर करें? तुषार जी, what you can do, see here, try to download each and every previous year paper of ESE. ठीक है, हर previous year paper को, some of the people recommend that go for the 10 years, but I would recommend you to go for the 20 years. ठीक है, सारा पेपर्स को आप डाउनलोड करें और सबको अच्छे से बनाएं, because the assertions and the reasoning questions are very much important in that. Concepts वहीं से improve होंगी और आप वहां से MCQ बनाएं. First of all, try to solve from that, and then you can go into the test series, enroll into the test series for the practice purposes. Sir, what is the difference between the offset with respect to the combined? See here, यहाँ पर difference क्या हो रहा है ना, देखिए लेद, देखिए यहाँ पर, see आशीष जी, basically earlier this was the tail stock, है ना, ये आपका tail stock का ये डेड सेंटर का पॉइंट था, यहाँ पर था, आपने डेड सेंटर को ऊपर कर दिया. ठीक है, मतलब कि पहले इसका पोजीशन यहां पर था, अब इसका पोजीशन कुछ और ऊपर जाकर के हो गया है, और इसी को बोलते हैं, दैट इज व्हाट आई हैव रिटन हियर, कि सपोज करें कि ये देखिए, सपोज दैट दिस इज योर समथिंग लाइक दैट, दिस इज योर dead center and this is your dead center, fine. So suppose this is the axis, somewhat here axis is there. Now what you are doing, you are just moving this dead center something like this by some amount in upward direction. Then what is you are doing, you are offsetting. offset मतलब क्या, जो अर्लियर सेक्शन था ना, जो अर्लियर आपका एक्सेस था, उस एक्सेस से रेस्पेक्ट में आप किसी और एक्सेस पर उससे इंक्रीज कर रहे हैं डिस्टेंस, आइदर इन द अपवर्ड डायरेक्शन और इन द डाउनवर्ड डायरेक्शन. दैट इज नोन एज द ऑफसेट. ओके, दैट इज नोन एज द ऑफसेट. सो आई होप नाउ यू हैव गॉट द आइडिया. टेल स्टॉक ऑफसेट मेथड में ये हम कर रहे थे, और कंपाउंड स्लाइड में जो है ना, हमने कंपाउंड स्लाइड को ही टैपर एंगल दिया है. बट सी इन दिस केस, इफ यू वुड see here, basically if you would see here, the dead center would be something like this. ठीक है, कुछ इस तरह का होगा. So this was going to be your dead center. ठीक है, that is not offset, that is at the lead central axis. Clear? This point is clear to you or not? So till now, if you have any kind of doubt, definitely you can ask with me. Otherwise, I am going to proceed with some of the numerical questions to get your concepts clear in a very good manner. ठीक है, अगर आपका कोई डाउट है तो definitely you can tell me. Otherwise, what I will do, I will try to teach you the different things. Just tell me, any doubt in understanding anything till now? Any doubt in understanding anything, just let me know. Okay, thank you so much. Now try to understand. So just now we have studied about the turning operation, isn't it? So turning operation में इतना सारा कुछ होता है, and in the taper turning, methods are there, that either you can go for the form tool, or you can go for the compound slide, or you can go for the offsetting tailstock. There is another method also, but that I am not teaching you that method, because see, गेट पॉइंट ऑफ व्यू के लिए सिर्फ इतना ही इंपॉर्टेंट है, नथिंग मोर. सी, बहुत इंपॉर्टेंट है क्या आपको पढ़ना है, ये जरूर जानिए किसी भी एग्जाम को क्लियर करने के लिए, क्योंकि बहुत कुछ होता है आपके सिलेबस में नहीं होता है, दैट इज नॉट नीडेड. बट वी स्टूडेंट हैव अ टेंडेंसी टू कवर इंटायर सिलेबस, और इंटायर के चक्कर में क्या हो जाता है, आपके पास तो स्ट्रेंथ ऑफ मटेरियल है, आपके पास तो थर्मोडायनेमिक्स है, आपके पास इंडस्ट्रियल है, आपके पास मैन्युफैक्चरिंग है, आपके पास सोम है, आपके पास डिजाइन है, आपके पास फ्लूइड है. क्या करिएगा, कैसे बैलेंस करिएगा? इसलिए सारा चीज को बिल्कुल भी ना कवर करें, कवर उसी को करें जो सिलेबस में है. सो दैट इज द थिंग, फाइन. नाउ लेट अस ट्राई टू सॉल्व सम ऑफ द प्रॉब्लम्स. suppose that there is a mild steel. Okay, suppose there is a mild steel, and in that mild steel you are performing the turning operation. Okay, suppose the length of workpiece is given to be as 200 mm. Fine. And the initial diameter is given to be 52 mm, final diameter to be your 44 mm. In this, suppose that you are going for the roughing operation. What is the meaning of roughing operation? अगर किसी भी प्रोडक्ट को अगर हम बनाते हैं, when you are going for the manufacturing of any product, first of all you do the rough machining. Okay, rough machining करते हैं, उसके बाद जब outer surface को आपको finish करना होता है, so for that purpose you go for the very high speed and less feed. हाई स्पीड एंड लेस फीड. ओके, तो उससे क्या होता है, आउटर सरफेस का फिनिश बहुत अच्छा होता है. तो सपोज फॉर द रफिंग ऑपरेशन यू आर गोइंग विद द मैक्सिमम वेलोसिटी is your 35 meter per minute and feed that you are giving is 0.3 mm per revolution. Also the depth of cut that you are giving is 3 mm. And for the finishing operation, for the finishing operation for the finishing operation, suppose the maximum velocity that you are getting is 50 meter per minute, feed is 0.1 mm per revolution and depth of cut is 1 mm. Please try to find the time required for machining. See, try to understand कि machining operation में first operation that is happening is roughing operation, second operation that is happening is finishing operation, and you need to find total time required for the machining. Can you find the total time? Can you find the total time, my dear friend? Can you find the total time? Please just let me know, yes or no. क्या आप total time find कर सकते हैं? This is the length of the workpiece, and assume that approach length is given as 5 mm. Can you find the total time required for the machining operation? Just let me know. If you can find it, then I would give you time. Otherwise, if you cannot find it, just let me know that, sir, I cannot find it, and then I will proceed for this solution. Just let me know. Please let me know. Please let me know. Okay, so I would be giving you some time. Take 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 60 seconds and try to solve this problem, and then I would be discussing this problem. Basically, see, I am giving you the hint how you can find it. You can find the, first of all, try to find the time which is taken for this case, that is the T1, time for this case, that is the T2, and then you can find the total time. So basically, how you can find the time? Remember that formula that I have told you, my dear friend. Time आप कैसे निकाल सकते हैं? How you can find the time? You can find the time by this formula, that is length of the workpiece plus approach distance by the feed velocity. Deepak ji, see, this is the course which is totally focused for the GATE point of view. But what I can say from my side is that that in the diploma also, in the workshop technologies, these things are there. Okay, and if you are able to understand these basics workshop functions, then I'm pretty much sure that you would score a very high marks in your examinations. Okay, I'm teaching since this is the third month. Is revolution given? Assis, try to find the revolution from this data given. From this data given itself, you will be able to find the revolutions. See here. what is the V is equal to pi d n, isn't it? V is equal to pi dn. Now you know that this is what is the velocity, है ना, यही आपका velocity होता है. लेकिन try to understand that if you are dividing this by 1000, okay, if you are dividing this by the 1000, then you would be getting in answer would be in revolution per minute, because basically this would be in mm. ठीक है. Now from here you can find it, from here you can find the velocity, from here you can find the n, from here you can find the n. So try to find the n for the first case and for the second case try to find the n. ठीक है. अभी आपने जब n फाइंड कर लिया ना, उस n को फाइंड करने के बाद मल्टीप्लाई विद द फीड, सो f into n would give you the feed velocity, so what you can do it, total distance traveled by the feed velocity would give you the time, and this is what I am telling you to calculate. So from here you can calculate the t1 for the first case, and for the t2 again repeat the same process, and you will be getting the t2, and from here add it t1 plus t2 and you will be getting the answers. Okay, so try to solve it, try to solve it. Try to see here, my dear friend. Try to see here, my dear friend. Now try to see here. Please, please, please see here how I am doing the solution, and then try to analyze what was your setup in your mind when you have first saw these questions. Okay. कंपैरिजन करने से ही आपका थिंकिंग एबिलिटी बढ़ेगा, क्योंकि किसी भी क्वेश्चंस को देखने के बाद द फर्स्ट थिंग दैट यू शुड ऑलवेज रिमेंबर हाउ टू अप्रोच दैट क्वेश्चन. फाइन. सो ट्राई टू अंडरस्टैंड दैट सपोज द फर्स्ट roughing operation is going on. So suppose that a roughing operation is going on. So how you can find the n? So n can be found by v into, see here, see this formula, v into 1000 by pi into d max. That is given in the problem. See, the v max is given as 35 meter per minute. Why I am telling here that Vmax is there? Since Vmax is there, hence you have to take the Dmax. That is the initial is diameter is your Dmax. Fine. This is your Dmax. Clear? So what you can write, that is your 52 mm, and this is your 35 meter per minute. So you can write it here that this is your 35 into 1000 by pi into 52 mm. Clear? So its unit was in meter per minute, and this is going to be your, so answer would be here something like that, 214.24 rpm. Now if you are talking about the finishing operation, then how you can find the n? So from this operation also you can find that v into 1000 by pi into Vmax. But what should be kept in the mind, that for the roughing operation this was your Vmax, for the finishing operation this is your 50, which is given as the finishing which is given as the Vmax. So you can put it here 50 into 1000 by pi into 44. Okay, that is the 44. So just let me know, just a minute, let me try to calculate it. So that would be coming to be around 361. Clear? That is coming to be around as 361.715. This is going to be your in rpm. Okay. Now try to understand what will be your time required for the roughing operation. Sir, we can use this formulas as v is equal to pi dn by 60. Definitely you can use that. That is the formula that I have used, my dear friend. That is the formula that I have used. That is the formula that I have used. And see, uh, Sharma ji, see here, my answer is in revolution per minute, है ना, revolution per minute में है ना, revolution per minute में. अगर आप इसको revolution per second में convert करते हैं तो आप इसको 60 से divide कर देंगे, है ना. समझ में आया या नहीं आया? Understood or not? And from here now try to calculate the time required for the machining operation. Time required for the machining operation. So basically this is coming to be your total length. See here, अब यहाँ पे देखें हो क्या रहा है. यहाँ पर ये कुछ इस तरह का वर्क पीस था आपके पास, है ना. ये वर्क पीस था और इस वर्क पीस को आपने चक में बांध दिया. ठीक है, चक में बांध दिया. एंड सी हियर that will be your tool is something like that. This is your tool. So what is the approach distance in this case? What is the approach distance? So this would be your approach distance, and this is the length of the workpiece. This is the length of the workpiece, and this is the length of the approach distance. Fine, this is the approach distance. ठीक है. अभी आप देखें यहाँ पर ओके, फिनिशिंग ऑपरेशन में से डी मिनिमम लेना है, डी मैक्स. ओके okay 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 let me check it. Let me check the things if I have done any kind of mistakes. N would be 52. Yes, that is correct. No, that is correct. That is correct. Now try to understand that this is the total distance. So total distance will be what? Total distance will be what is the total distance? Total distance will be L plus A. So basically the length is 200 mm, the approach length is 5 mm. So you can say that total distance that will be traveled by the tool will be 205 mm. ठीक है, 205 mm tool को travel करना पड़ेगा. ठीक है. So from here what you can write that Tm for the roughing operation would be written as distance traveled by F into N. Now see, what is the distance traveled? That is 205 mm. And what is the feed? So feed for the roughing operation is given as 0.3 mm per revolution. Okay, so that is 0.3 mm per revolution. And what is the N? N just now you have calculated, that is 214.24. So put it here, 214.24, and that will be if you will calculate, that will be coming to be 3.19 minutes. Now for the this is all about for the roughing operation. Now for the finishing operation, how you can find the time required for the machining? So you can find by the time required. So what is the time required? That is again 205 total distance by F into N. So in this case, what is the F into N for the finishing operation? For the finishing operation, this will be your N, and for the finishing operation, this will be your feed. Okay, so just put it here, 205 mm by feed is given as 0.1 mm per revolution into N is, you have calculated at 361.71, and from here you can find the Tm. From here you can find the Tm, that will be coming to be somewhat around 5.66 5.66 5.66 minute. ठीक है. Now see here, this is the machining time for the roughing operation. This is the machining time for the finishing operation. So the total time would be given as 3.19 mm plus of 5.66, I am writing this, minute plus 5.66 minute, and this would be just just add it and then you will be getting the answers. Okay, that will be 8.85. ठीक है, 8.85. Understood or not? Understood or not? Any doubt in these kind of problems? See here, so what you can understand, see what is the learning in this case, what is the learning in this case, that even if you are not given, even if you are not given the n, so you can use these kind of formula to find the n. ठीक है, ये यहां से लर्निंग आपका आया है ना. चलिए, अब एक क्वेश्चन मैं आपसे और एक क्वेश्चन आपको कराता हूं. यू विल बी इंजॉइंग दीज क्वेश्चंस, है ना. मैं क्वेश्चंस जो आपको कराऊंगा, आपको बहुत ही इंजॉयमेंट मिलेगा क्वेश्चंस को देख करके, क्योंकि ये रियल में ऐसा आप करते हैं. सपोज दैट अ क्वेश्चन इज देयर समथिंग लाइक दैट. सपोज सपोज दिस इज अ workpiece. Fine. So suppose initially you have the workpiece which is having the diameter, as 60 mm. Okay, and its length is 215. Suppose its length is 215 mm. Okay, now you need to do a turning operation, or basically you need to machine this workpiece and make something like this. Okay, so something like this you want to machine, and t average ले सकते हैं क्या इसमें, किसमें, for this problem or for the earlier problem? There is no questions of d average my dear friend. मिश्रा जी, यहाँ पे डी एवरेज की कोई सवाल नहीं उठती है. ठीक है, चलिए यहाँ पे देखिए, यहाँ पर देखिए, फॉर दिस प्रॉब्लम इफ यू आर टेलिंग, डेफिनेटली डी एवरेज की कॉन्सेप्ट यहाँ पर आएगा. अभी यहाँ पे देखिए 215 है. सपोज दिस डायमेंशंस इज समथिंग लाइक दिस. सपोज this dimension is 54 mm. This is 100 mm. This length is 115 mm. Clear? This diameter is 42. Now try to understand that in the machining operation you are giving the depth of cut to be your 3 mm, and feed that you are giving is 1.2 mm per revolution, and the velocity by which you are cutting this is known as, is given by 20 meter per minute. Then please try to find the time required for the machining operation. Please find the time required for the machining operation. Can you solve this kind of problem? क्या आप इस तरह के प्रॉब्लम को सॉल्व कर सकते हैं? यस और नो, जस्ट लेट मी नो. अर्लियर, नो 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 मिश्रा जी, अर्लियर में नहीं करेंगे. वहां पर डी एवरेज की कोई जरूरत ही नहीं है, क्योंकि उसके बिना ही हम अपना आंसर्स को निकाल रहे हैं. ठीक है, क्योंकि दो ऑपरेशंस आप उसमें कर रहे हैं. एक ऑपरेशन इज योर रफिंग ऑपरेशन, फर्स्ट रफ आपका रफ मशीनिंग कर ले रहे हैं, और दूसरी बात फिनिशिंग कर रहे हैं. सो दो ऑपरेशंस हो रहा है ना, तो इसलिए थोड़ा सा अलग यहाँ पर अप्रोच हमने किया. और देखिए सबसे बड़ी बात है कि उस केस में डायमीटर्स भी तो नहीं गिवन है ना. डायमीटर्स आपका ये गिवन है कि फाइनल ये हो गया, इनिशियल ये हो गया, लेकिन आपका जो पॉइंट है ना कि ये दोनों रफिंग ऑपरेशंस और फिनिशिंग ऑपरेशंस अलग अलग है. सो इसलिए हमारा थोड़ा सा प्रोसेस अलग अलग आ गया है, क्योंकि एक इसके लिए अलग हमने निकाल लिया और इसके लिए अलग हमने निकाल लिया। ठीक है, टाइम रिक्वायर्ड फॉर मशीनिंग। कैन यू सॉल्व दिस प्रॉब्लम? See here, first and foremost thing that you should remember in this problem, and what you need to see here is depth of cut is given as 3 mm. What is the meaning of depth of cut? What is the meaning of depth of cut? So in a single pass, अगर आपने सिंगल पास दिया और सिंगल पास देकर के जब आप मशीन कर रहे हैं, when you are giving a single pass in machining, then maximum depth of cut that you can give is, my dear friend, 3 mm, not more than that. Okay, so try to understand that earlier this 60 mm was the diameter of the workpiece. ठीक है, okay, don't worry Ashish and everyone, please try to see here how I am solving this problem, and then you will be getting a better idea how to approach these kind of problems. ठीक है, see here, नो वरी नीरज जी, नो वरी, आप यहां से भी फॉलो कर सकते हैं, कोई दिक्कत नहीं है। अभी सपोज करें कि लेथ में ये वर्कपीस गिवन है और आपको ये बनाना है, तो फर्स्ट थिंग दैट यू शुड ऑलवेज रिमेंबर दैट व्हाट विल बी द फर्स्ट पास कंडीशन. So what you can see here, that in the first pass the n is given by v into 1000 by pi into d average. ठीक है, d average. अभी देखिए डी एवरेज की कॉन्सेप्ट यहां पर हमने क्यों लाया और यहां पर हमने क्यों नहीं लिया, क्योंकि आपको एक बात मैं बताऊं कि इस कंडीशन में ये था आपका इनिशियल और ये था फाइनल, तो यहां पर गिवन था कि एक ही पास में आपका ये बन जा रहा है. इन अ सिंगल पास यू आर अचीविंग दिस, बट इन दिस केस you cannot achieve these kind of thing in a single pass. Why you are not achieving in a single pass? Think about it, that if this is your 60 mm, then when you are giving a depth of cut, so depth of cut अगर आप देते हैं, so depth of cut कितना होगा, so basically this will be 3 mm depth of cut in this side, and this will be a 3 mm depth of cut in this side, isn't it? So basically the maximum possible reduction in the diameter what you can do, which is 60 mm, तो यहां पर जो डेप्थ ऑफ कट 3 mm और 3 mm यहां पर आप दे रहे हैं, so maximum reduction would be 6 mm. So 60 minus of 6 will be given as 54 mm. So that is why you can see here that in a single pass, when you are doing a single pass operation, then what you are doing, you can achieve 60 mm to 54 mm. ठीक है, 54 mm अचीव कर रहे हैं, क्योंकि डेप्थ ऑफ कट यहाँ पे कितना है 3 mm का, तो 3 mm इस साइड and 3 mm this side, so that will be 6. So for that condition, what you can write here, what will be the v is given as 20 into 1000 pi. What will be the d average, my dear friend? See here, d average यहाँ पर क्या होगा, तो d average यहाँ पर आप देखें 60 mm पहले था, 54 बाद में था, so can you write like that, 60 plus of 54 pi. Clear? So that will be your n, and now if you will calculate it, you will be getting as 111.7 rpm. Fine, 111.7 rpm. Now if I would be asking that what is the time required in this machining operation, so total distance was 215, so total distance is 215, and the feed is given as 1.2 f into n, right? Remember f into n, so this is 215, f is given as 1.2, and n is 111.7. this would be, you can calculate it and you will be getting as t1 is equal to 1.6 minute. ठीक है, तो एक चीज आप जो यहाँ पे समझें कि अर्लियर आपके पास कुछ इस तरह का था मटेरियल, that is something like this 60. Now what you have done, you have reduced its diameter, and this is now in this condition it is something like this, that this is your 54, This is your 54. Okay, so this is the operation that you have done. This is the operation that you have done. 111.668. Very good, very good, very good. Very good, Mr. Ji. Your answer is correct. Now see here. This is what is you have done. So this is, you can say that this is the thing that is happening in the first pass. ठीक है, फर्स्ट पास में यही हो रहा है. अभी आप सोचें, नाउ ट्राई टू थिंक इट दैट व्हाट इज द डेप्थ ऑफ कट यू आर अप्लाइंग. दैट इज द 3 mm. 3 mm से ज्यादा डेप्थ ऑफ कट आप अप्लाई नहीं कर सकते हैं. सो सपोज दैट इफ यू वांट टू मशीन एंड गेट समथिंग लाइक दैट, तो अगर आपको 42 mm का मशीनिंग यहाँ पर कट करना है, suppose that if you want to machine it, see this is what you want to machine, this is what is you want to machine, and this is your 42, है ना. यही तो कुछ आप करना चाहते हैं. 42, this is what you want to machine, but as a matter of fact you cannot extend the depth of cut more than 3 mm. so what is the meaning of here that 3 mm यहाँ से हुआ, 3 mm यहाँ से हुआ, so maximum आप 6 mm ही reduce कर सकते हैं यहाँ से. so अगर maximum आप 6 mm reduce कर रहे हैं यहाँ से, so what is the meaning, 54 mm is the total diameter, and maximum you can reduce the 3 mm. this is the 3 mm and this is the 3 mm, so maximum you can reduce the 6 mm. so from here you can understand that this will be 48 mm. मतलब क्या, मतलब is that in the third pass what you can do it here, you can get something like this. This will be your 48 mm. This will be your 48 mm, isn't it? And this will be your 54 mm. Have you understood this or not? Have you understood this or not? So basically in that case, this is happening in the second pass. So for the second pass, if you would calculate the D average, that will be 54 plus 48 by 2, isn't it? This is going to be your D average, है ना? So now let us try to find the answers for the second pass. ठीक है. So second pass में हमने n को कैसे निकालना है? n would be, you again see v into 1000 by pi into D average. So v is again 20 into 1000 by pi into D average. So in this case D average is 54 plus 48 by 2. Put it here, 54 plus 48 by 2. Put it here, and then you will be getting the value of n, and that would be something around 124.8 rpm. Let us talk about the distance traveled during the machining. Okay, so time required in that machining would be distance traveled by f into n. Now see here, what is the distance traveled, my dear friend? Can you tell me? This is the amount by which, this is the distance, this is the distance that your tool has moved. So in the figure you have seen that this is your 100 mm, this is your 115, this distance is your 100 mm, this is your 115 mm. So basically what you can write here, that distance traveled will be 115 mm by f into n. What is the feed? What is the feed? Feed is 1.2 mm per revolution, and what is the n, my dear friend? N you have calculated as 124.8. so feed will be 1.2 into 124.8. and when you will be calculating the, so basically let us assume this to be second pass, so T2 will be coming to be 0.77 minute. This is 0.77 minute. Have we reached our final desired diameter things? हमें बनाना था 42, हमने बना डाला 48, लेकिन 42 तो अभी भी अचीव नहीं हुआ, है ना? Still now we have not achieved it. So again what we will do it here, again we will give again a depth of cut would be given to it. So basically that will be here. So again let us try to understand, this is the depth of cut that we will be giving from this side. So suppose this distance is 3 mm, this distance is 3 mm. So again after that what you will do, you will get 54, this is your 54 diameter, and here will be, this will be your 42, because from here this is 3 mm, from here this is 3 mm, so 6 mm for total distance you are getting as 6 mm, you can reduce it, so 48 minus 6 mm is going to be give you 42. So you are now achieving the 42 mm here. Here you are achieving 54 mm, isn't it? तो अभी आपका ये फाइनल डायमीटर आ गया. So now what is the D average for this case? But before that, this is your third pass. ठीक है, ये थर्ड पास हो गया. एंड इन दैट केस डी एवरेज वुड बी 54 प्लस 42 बाई 2, isn't it? ये आपका डी एवरेज हो गया. और फॉर द थर्ड पास try to calculate the values. What will be the n? N will be 20 into 1000 by pi into d average. What is the d average? So basically the d average will be 54 plus 42 by 2. 54 plus 42 by 2, and this will be your n. From here you can find the n to be 141.5 rpm. Now from here what will be the t3? T3 will be distance traveled. So what is the distance traveled? 115 mm है ना. यही तो distance travel हुआ, यही तो distance travel हुआ ना. 100 and this is the distance that is traveled by you, 115 mm. So this, put it here, by f into n. What is the feed? Feed is given as 1.2 into n is given as 141.5, and from here you can find t3 as 0.67 minute. Now what is the total time required for the machining? Total time required for the machining would be t1 plus t2 plus t3. So total time will be t1 plus t2 plus t3. So that will be 1.6 minute for the t1. See here, 1.6 minute for the t1. t2 is 0.77 and t3 is 0.67. So put it here, 0.677 minute. This will be 0.67 minute. That will be coming to be as let me calculate it. 1.6 0.77 that will be 3.04, isn't it? So that is going to be your 3.04. That is the total time. Have you understood this entire question? Yes or no? Yes or no? Please tell me, have you understood this entire question? Yes or no? Because that is a very good question. ये questions अगर कर लेते हैं आप, इस तरह के questions अगर आपके दिमाग में घुस जाता है, then my dear friend, you can solve any problems from these kind of topics. ठीक है, इस टॉपिक से आप कोई भी प्रॉब्लम को सॉल्व कर सकते हैं. Any doubt in understanding anything? Most welcome, everyone, most welcome. Definitely you can raise the issues if you are not able to understand the problems. Definitely you can tell me. अभी देखिए, मैं आपको एक और एक चीज जो बताना चाहता हूं. See here, after understanding this question, you are now in a position that suppose that if someone is telling you time required for the machining, to find the time required for the machining, you can write that L equivalent length by f into n. Now see, if in the question it is explicitly mentioned that you are doing n number of pass, suppose this n is number of pass, है ना. नंबर ऑफ पास अगर आपका गिवन है क्वेश्चन में और यूनिफॉर्म डेप्थ ऑफ कट आपका चल रहा है, तो यू कैन यूज दिस फॉर्मूला इटसेल्फ to find the machining time itself. Otherwise what you can do it here, you know the process, then you have to do that LE by FN. Try to find this first for the first case. Here for that cases you need to find the n by v into 1000 by pi into d average, है ना. यहाँ से आपको n फाइंड करना है. ठीक है, n फाइंड करने के बाद आपको यहाँ पर पुट करना है और हर एक प्रोसेस कर करके आपको नंबर ऑफ पास निकाल करके आपको फाइनल मशीनिंग टाइम निकालना है. ठीक है, दैट इज द प्रोसेस बाय विच यू कैन सॉल्व द प्रॉब्लम्स. ठीक है, चलिए, कोई डाउट नहीं है. आई एम वेरी हैप्पी दैट ईच एंड एवरीवन इज अंडरस्टैंडिंग द थिंग्स. नाउ सी हियर, basically 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 if you could see the lathe, then in the lathe क्या होता है ना कि आपका गियर बॉक्स अरेंजमेंट होता है, और इन दैट अरेंजमेंट दिस इज द चक, है ना. ये जो चक होता है ये कुछ इस तरह का चक होता है, एंड दिस चक इज रोटेटिंग समथिंग लाइक दिस, है ना. ये रोटेट करता है. नाउ from where you are giving the power, so basically a gearbox is there from where you are giving the power to this chuck. Now sometimes in the practice it is very much required to select the speed, by what should be your optimum speed, or what should be your speed by which you can do the machining operation, isn't it? So this topic would deal you about the speed selection. Now see here, basically number of spindle speed, स्पिंडल मींस दैट इज द स्पिंडल, है ना, चक के अंदर जो रगा रहता है वो. तो स्पिंडल एक्सिस का जो स्पीड होता है वो बेसिकली दैट स्पीड इज, स्पिंडल स्पीड इज इन ज्योमेट्रिक प्रोग्रेशंस. ठीक है, दैट स्पीड इज इन ज्योमेट्रिक प्रोग्रेशंस. वो जो है ना वो जीपी के सीरीज को फॉलो करता है. व्हाट आई मीन फ्रॉम दैट कि जीपी के सीरीज को फॉलो करता है, दैट सिंपली मीन्स दैट सपोज दैट if you are going for that, suppose like n1 is the first speed you have made, suppose n2 is the second speed, n3 is the third speed, n4 is the fourth speed, dot 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 dot. Now what I am trying to say here that it is this speed ratios है ना, जैसे जैसे आप गियर ट्रेन की वैल्यूज को बढ़ाएंगे वहां पर तो स्पीड रेशियोज बढ़ता है. अभी ये जो स्पीड रेशियोज है, दिस स्पीड रेशियोज आर फॉलोइंग अ ज्योमेट्रिक प्रोग्रेशंस सीरीज, जीपी के सीरीज को फॉलो करता है. एंड इफ दैट इज ट्रू, इन दैट केस माय डियर फ्रेंड, you can write this as n1 as n1, n2 as n1 into r. So this is r which is by which this gp series का इफेक्ट केयर किया जाएगा. So that is n1r, this is n2, just a minute, this is n1 r square, this is n1 r cube, and dot 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 dot, this will be, suppose at the last, that will be n1 r to the power of n minus of 1, where what is the n? So basically the n is the number of spindle speed required with n1 be the minimum speed. अभी एक चीज आप यहाँ पे नोट करें, प्लीज नोट दिस थिंग दैट दिस n1 इज वेरी लेस इन मैग्नीट्यूड, इजंट इट, क्योंकि ये मल्टीप्लाई होगा r से, एंड बेसिकली ये r से मल्टीप्लाई होगा, दैट इज ऑल्सो नोन एज स्पीड रेशियो. ठीक है, ये r से मल्टीप्लाई होगा, दैट इज नोन एज स्पीड रेशियो. सी हियर, बेसिकली n2 by n1, n2 by n1 is given by this thing, right? ये आपका n2 by n1 is equal to n3 by n2 is equal to n4 by n3 is equal to, इस तरह से आपका चलते जाता है. ठीक है, ये स्पीड रेशियोज आर गोइंग टू बी कांस्टेंट थ्रू आउट दिस. So this is what is happening. Now you can understand this n1 is minimum and this is maximum speed, है ना. ये जो speed होगा, this will be your minimum speed and this will be your maximum speed. This will be your maximum speed. Now in the GATE examinations, from where you will be getting the questions, my dear friend, basically try to understand in the GATE you may be asked that suppose the n minimum is given as 100 rpm, okay, and n maximum is given as 1000 rpm, and they're telling that total number of number of spindle speed required with n1 being the minimum speed. So total n जो आपका number of spindle speed required है, that will be given in the question. Suppose that is 8, then they will be asking find the fifth speed. So how can you achieve this kind of problem? How can you achieve this kind of problem? Tell me. Do you have any idea how can you achieve this kind of problem? This is a basic question of GP. Mathematics का problem बन गया अब ये. Can you tell me how can you find it? Definitely, you're most welcome, Neeraj ji. I have already covered the machining lectures, and that machining lecture you can find. You can check this link, है ना? आप इस वीडियो के डिस्क्रिप्शन में चले जाइएगा, and in that description you will find a link that will be giving you that link will be of 12 lectures that I have given, 12 lectures of the machining, है ना? ये machining का 12 lectures मैंने डाल दिया है. वो आप 12 lectures को आप पढ़ लें और ये इसके बाद ये कंटिन्यू कर लें, and then your entire manufacturing would be solid. इतना solid हो जाएगा आपका manufacturing कि आप फिर मतलब आप कहीं भी जाएंगे, you will be telling that my favorite subject is manufacturing. That's it. आपको कोई क्वेश्चन पूछना, आप मेरे से मैन्युफैक्चरिंग में पूछें और कोई क्वेश्चंस ना पूछें. That is the way I am teaching you, and I hope everything would be आपको सब समझ में आ रहा होगा with formula of AR की power n-1. Okay, see here basically, see here, देखिए यहाँ पे देखिए, ट्राई टू अंडरस्टैंड फर्स्ट थिंग कि यहाँ पर n क्या है, 8 है क्या? तो कैन यू राइट दैट n8 सी हियर. यहाँ पे देखिए, जब n3 था तो n1r स्क्वायर हो गया, n4 था तो n1r क्यूब हो गया, तो n1r टू द पावर n-1 हो रहा है. तो कैन यू राइट लाइक दैट, कैन यू राइट लाइक दैट n8 विल बी n1r to the power 7, isn't it? R to the power 7, because this 7 will be n minus of 1 where n is 8, isn't it? Where n is 8. So from here you can write that n8 is given. See here, अगर 8 है तो this n max is what? N max is n8 and this n mean is n1, है ना? यही तो आपको समझ में आ रहा है. So that will be your 1000 rpm is equal to n1, that will be your 100 into ratio, speed ratio, you can find it from here. So from here you can find that will be 1.389. Now once you have find that r is equal to 1.389, then what you can find, you need to find the fifth speed. So how you can find the fifth speed? Fifth speed will be is equal to first speed into speed ratio to the power of 4, है ना? यही तो आपका हो रहा है. तो what is the n1? N1 is given as 100 rpm, put it here, 100 rpm, and r is given as 1.389, that will be n5, that will be n5, and from here when you will calculate, that will be 372.7 rpm. Very good, very good, very good, very good, Asis, very good. So definitely now what you can do here, you can open the previous year gate papers and try to solve the problems. अब देखिएगा आपका problems कहीं रुकेगा नहीं. Now your problems, each and every problem you will be able to solve it. Have you understood this concept? Yes or no? Just let me know. Have you understood this concept? Yes or no? So basically the speed ratio can be found out by n max by n minimum, isn't it? n max by n minimum. ठीक है. अभी अगर सपोज करें कि आपको n max फाइंड करना है, think about it, you need to find the n max. So to find the n max you need to give the v, see here, if you need to find the n max, then you need to find the v max into 1000 by pi into, see, if you need to find the n max, then you need to do the n mean, d mean, है ना? d minimum, अगर मिनिमम डायमीटर को आप यहाँ पे लेते हैं तो ही आपको मैक्सिमम n मिलेगा यहाँ पर. और अगर आप इस जगह पर मिनिमम वैल्यू निकालना चाहते हैं, then what you need to do it, v minimum into 1000 by pi into d max. Now you got the n minimum, you got the n max, try to substitute it here, try to substitute it here, and you will be getting as speed ratio that is given by n max by n mean is equal to v max by v mean into d max by d mean. This is going to be your speed ratio. So sometimes in the problem you may not be given everything, but you will be given something like these things would be given to you. So what you can do, you can apply these things और आप solve कर सकते हैं problem को. ठीक है. Suppose that in a machining operation there are 6 spindle speed using ड्रिल्स है ना. आप ड्रिलिंग का ऑपरेशन अगर कर रहे हैं तो उसमें आपको 6 स्पिंडल स्पीड्स लग रहा है. सो ड्रिल्स ऑफ diameter 6.25 mm up to 25 mm. If the cutting speed is 18 mm per minute, find the ratio between two consecutive spindle speed. Now this kind of questions you may expect in the GATE. So how to approach it? How to approach this kind of problem? In this ratio between the two consecutive spindle speed is given. तो ये आपको फाइंड करना है. अभी आपको गिवन यहाँ पे क्या है कि आप यू आर यूजिंग द 6 स्पिंडल स्पीड्स आर देयर एंड यू आर यूजिंग अ ड्रिल बिट एंड विद द ड्रिल बिट यू आर डूइंग द ड्रिलिंग ऑपरेशंस एंड दिस इज द मिनिमम डायमीटर दैट इज गिवन टू यू और ये आपका मैक्सिमम डायमीटर गिवन है. सो व्हाट यू कैन सी हियर फ्रॉम दिस, द मिनिमम इज गिवन टू यू इज 6.25 mm. The maximum is given to you as 25 mm, and from here you know that the Vmax, that is the cutting speed. So in this case this is your Vmax and this is your Vmean. So what you can say here, that maximum speed is the same and the minimum speed is also the same. That is nothing but the cutting speed. And whose magnitude is 18 mm per minute. So how you can find it? So you can write it here as n max by n minimum is equal to V max by V minimum into D max by D minimum, and you know that V max and V mean both are same, so that will be cancelled out. So you will be left as 18 by 18 actually into 25 by 6.25. This will get cancelled out and this will be coming to be 4. So what you have seen, that n max is equal to n mean r to the power of n minus 1, isn't it? R to the power of n minus 1, and from here you can write that r can be written as n max by n mean to the power of 1 by n minus 1. ठीक है. अभी देखिए n max by n mean आपने क्या निकाला, that is the 4. Put it here, that will be 4 to the power 1 by, see what is the total spindle speed, that is the 6 is given, isn't it? See here, 6 total spindle speed is given, 6 है ना. So what you can write here as 6, so that will be 6 minus of 1, that will be 4 to the power of 1 by 5. So R value would be 1.33. This is the value that was asked and you have found the answer. Now any doubt in understanding these kind of problems? कोई doubt है क्या? Any kind of doubts? Because each and every questions are very easy, but yes, you need to apply some of your brains, है ना. कुछ तो आपको दिमाग apply करना पड़ेगा for getting the answers. Any doubt? Just let me know. Okay, so I assume that no doubt is there. So definitely let us try to move to our next topic, that is errors. Okay, लकी जी का आंसर आ रहा है 4. yes, 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 4 आंसर आएगा आपका n max by n mean, and then you can find the value of r. ठीक है. Now see here, let us try to understand another topic, that is tool setting error. Now see, from this topic of tool setting error, not a single question has been asked till now, but this is a very very easy section, बहुत ही छोटा सेक्शन है. तो मैं ये टॉपिक आपको क्यों पढ़ा रहा हूँ, द सेम रीजन इज दैट बिकॉज there might be some experimentation. Okay, so for that reason, this is a very small topic and there is nothing new you have to extra you need to do it in this question. Just you need to understand the basics. Abhi tak koi question pucha nahi gaya, but there is a chance that questions may be asked. So what is a tool setting error? So first of all, try to understand that what is the ideal positions. So first of all, suppose that this is your cross sectional part, and on this what you are doing, you are giving a, so this is what is your single point cutting tool, isn't it? This is what is your single point cutting, this is what is your single point cutting tool. Okay, now in this single point cutting tool, what you can understand is that suppose, okay, this is your axis, this is your axis. Okay, so basically, if so this is your ideal conditions. So in that conditions, what you can understand, that this is my spindle axis, and on this axis only my tool is actually lying on that part. So this is your ideal position, this is your ideal position. Now try to understand, when you are giving some tool offset, suppose you are giving some tool offset above that part, what is that? You will be able to understand. Suppose this is your workpiece, and on this workpiece, this was your ideal position, this was your ideal position. Now what it has been done, now your tool has something like that. क्या होता है ना, कभी कभी मशीनिंग के दौरान गलतियां हो जाती हैं मशीनिंग ऑपरेशन में, and due to that the change in the shapes are observed. Okay, suppose this is your tool, ideal position was this was your ideal position, isn't it? लेकिन अभी जो टूल है ना, अभी जो टूल है वो कुछ इस तरह का डिस्टेंस मूव कर रहा है ना, this is the distance that is moving. Now try to understand, in this condition, this in here the normal force was acting, है ना, नॉर्मल फोर्स यहाँ पर एक्ट कर रहा था. ठीक है, so in that condition, this is the normal force that is acting. ठीक है, which is direction में normal force आपका एक्ट करेगा, and this whole thing will be radius r. This distance, this is denoted by x, this distance is denoted by x, this is x. Fine. Now this angle is theta. Okay, this angle is theta. Now try to understand. अभी एक चीज आप समझे, in this case, in the ideal position, this was your rectangle, isn't it? This was your rectangle, है ना, यही तो आपका rectangle था. और rectangle को हम कैसे डिनोट करते हैं? This is denoted by alpha. Now we are using the alpha as alpha in which is acting. Alpha is acting. Sir, can n be resolved in two components? Definitely n can be resolved in two components. See, n would be some in this direction and in this direction also. Basically in this, clearance angle would be, this will be in action. So see, in this you can write it as a thrust force. Okay, that will be thrust and that will be normal force. Okay, that will be normal force. Now it is clear to you. अब समझ में आ रहा है? Now see here, this is your N and this is the thrust force. Now from here, what you can see in this case, if you want to find the theta, you can write as sine theta would be is equal to x by r, where this distance is x. Try to understand, this distance is x, and this distance is r. ठीक है, ये आपका हो गया. लेकिन एक चीज आप सोचें, दिस वॉज योर अल्फा, ये आपका अल्फा एक्शन ये था ना, ये देखिए पहले केस में ये आपका अल्फा एक्टिंग था. नाउ व्हाट यू कैन से, व्हाट विल बी द नेट चेंज इन अल्फा. अभी नेट चेंज इन अल्फा क्या ये हो गया क्या, ये पूरा अल्फा में हो गया क्या वैल्यू. तो व्हाट यू कैन से दैट इन दिस केस अल्फा इफेक्टिव would be alpha acting plus theta. So this is by which your rake angle will be changing. So change in rake angle. So what you can say from here, that basically when the tool offset is above, है ना, above, then you are getting the change in the rake angle as alpha effective as this. ठीक है, अल्फा इफेक्टिव ये आ गया. अभी आप सोचें, अगर थीटा ऊपर में बढ़ रहा है तो थीटा नीचे में गिर रहा है ना. सी हियर, थीटा नीचे में गिर रहा है. So by this theta amount, this will be decreasing, this will be decreasing, this will be decreasing. So what you can get from here, that in this case C effective, that is the clearance angle, effective clearance angle, or better to write as gamma, because that is what you have seen. So gamma effective will be gamma into, which is acting, minus of theta. So by the theta amount, your clearance angle would be changing. So this is the change in clearance angle. Now similar thing will be analyzed when you are giving the tool offset below. So when you are giving the tool offset downward direction, then what is the thing that you will be getting? See here, ये हो गया आपका workpiece. This is your workpiece. Now this is your axis. Now suppose that this is your tool. Okay, this is your tool. Clear. Now in that condition, this would be your n, है ना. ये आपका n हो जाएगा, और ये आपका कुछ इस डायरेक्शन में आपका E हो जाएगा, मतलब thrust force हो जाएगा. So basically what you can understand, by the theta amount this thrust force is increasing. See, earlier thrust force was in this position, isn't it? Means in this position, that is the T. Now it is changing the distance, now it is changing its arrangement as T dash. So there is a change in the clearance angle. So what you can see in here in this figure, that clearance angle, so earlier clearance angle was alpha action, now the net clearance angle is this much, is the net clearance angle. So what you can understand from here, so theta is increased from this side, so theta will be decreased from the rake surface. So what you can say from here is that the alpha, so in this you can say here that gamma effective, that is a change in the effective clearance angle, that will be earlier whatever amount of alpha that was acting plus of theta, है ना. ये देखिए theta add हो गया यहाँ पे. This is the change in the clearance angle. And what is the change in the rake angle? So alpha effective will be given as alpha, which is acting, minus of theta. This is your change in the rake angle. ठीक है. So I hope you understood these things. Any doubt in understanding? Any problem? कहीं पर कोई doubt? Any doubt in understanding anything? Okay. Try to solve the problem. I'm giving you one problem and try to solve the problem. For turning operation, dia at one end is 80 mm and 65 mm at other end. If the length of workpiece is 90 mm and taper is done along a length of 55 mm, then find the taper angle and tailstock offset. Please find this question. Please find the answer of this question. Please find the answer of this question and tell me the answer. Please find the answer of this question and tell me the answer. Can you solve this problem? Just let me know. Just let me know, my dear friend. Can you solve this problem? सबसे पहली चीज तो आपको यहाँ पे समझना है कि सर क्वेश्चन में कह क्या रहा है. व्हाट इज द क्वेश्चन दैट व्हाट इज द thing that is being delivered in this question. So first thing that you should understand that this is your turning operation. Okay, so this is your turning operation. Fine. 9.52. No. No, 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 no. Any mistake is there? Some mistakes are there. Okay, try to understand that this is a turning operation and dia at one end is 80 and dia at one end is 65 है ना. एक एंड में आपका डाया 80 है और दूसरे एंड में डाया आपका 65 है. ठीक है. If the length of workpiece is 90 mm, basically this is 80 mm. I think it is not visible. End is 80 mm. And this is workpiece, length of workpiece. Now it is visible. Yes, now it is clearly visible. So what you can see here, in this case, see, basically a taper is done. Try to understand. एक डाया आपका 80 mm है एक एंड का, दूसरे एंड का डाया आपका 65 mm है. इफ द लेंथ ऑफ द वर्क पीस इज 90 mm, 90 mm is the length of the entire workpiece. Okay, 90 mm is the length of the entire workpiece and taper is done along a length of 55 mm only. So what you can see here, so the diagram would be something like that. Try to understand. If you could visualize these things, then you could solve these things. No problem would be there. But the problem is that visualizing is a very challenging part. See here, this is the Tmax value that is given as TMM. This value will be 80 mm. And the other end it is 65 mm, isn't it? It is 65 mm. So this will be 65 mm. And up, see, length of the total workpiece is 90 mm. So this is the total workpiece length is 90 mm. This entire length is given as 90 mm. But taper is done along a length of only 55 mm. So this is the distance which is up to till now. So this is the 55 mm distance up to which taper is done, isn't it? ये taper आपका किया गया. Now you know that this angle would be alpha by 2. Now just mere calculations are there. Now you can do the calculations and find the value. So Asis is given as 15.53. Yes, very good, Asis. Now please try to find the tailstock offset. Can you find the tailstock offset? Taper angle and tailstock offset. Can you find it? See here, you can find that alpha would be given by twice of tan inverse of d1, or better to write as d max minus of d mean by twice L small l. Let this distance to be small l. Okay, small l. So this is the small l. Okay, let me write this as d1, this as d2, because that is the notations that we have following throughout this. This is d1 and this is d2. So what you can do here, alpha would be twice of tan inverse of 80 minus of 65 by twice of 55, and from here alpha would be getting to be 15.53 degree. Clear? Now you can see here, you can always convert these things in cases of a minute if required. ठीक है, आप इसको मिनट में भी convert कर सकते हैं. How you can do it? You can do it as 15 plus 0.53 into 60 to convert in the this thing, and definitely from here you can get as 15 plus of, just a minute, so from here you can get as 15. So from here you can do the calculations. Okay, from here you can do the calculations if it is required in the problem. Now you need to find the offset. How you can find the offset? Tailstock offset, that is the length of the workpiece into sine of alpha by 2. What is the length of the workpiece? What is the length of the workpiece? Length of the workpiece is 90 mm, so you can put it here. Length of the workpiece is 90 mm. Sine of alpha by 2, that is 15.53 by 2. So tailstock offset would be coming to be 12.16 mm. ये हो जाएगा आपका tailstock workpiece, tailstock offset आपका. This would be your answer. Any doubt? Any doubt in understanding any problem? Anything? कहीं पर भी कोई doubt? कहीं पर भी कोई doubt? Any doubt? 12.14. What is 12.14? Okay, why? That's fine, that's fine, that's fine. Okay, very quickly I'm giving you one last question. Please try to solve and tell me the answer. So I would be waiting for your reply. In taper turning operation, length is 400 mm. So basically this is the length of workpiece. Length of workpiece is 400 mm and taper length is 100 mm. Taper angle is given as 4 degree. The tailstock offset will be option A 400 sine 2, option B 400 sine 4, option C 100 sine 2, option D 100 sine 4. Tell me the answer. Tell me the answer very fast. Very fast, please tell me the answer. Please tell me the answer. Please tell me the answer. A. Okay. 400 sine 2. What about others? What about others? Can you solve this problem? Can you solve this problem, my dear friend? क्या इस प्रॉब्लम को आप सॉल्व कर सकते हैं? See here, in this problem you have been given that length of the workpiece is 400 mm. So length of the workpiece, that is length of workpiece, that is given as 400 mm, and the alpha value that is given as 4 angle, taper angle है ना, ये taper होता है. Alpha is taper angle and that is given as 4 degree. Clear? That is given as 4 degree. Basically alpha by 2 is what? Half taper angle है ना. इन सब चीजों को भूलना नहीं है. दैट इज द हाफ taper angle. So basically they are asking about the tailstock offset. How you can find the tailstock offset? This is given by LW sine alpha by 2. This is the length of the workpiece. So length of the workpiece is 400 mm. Put it here, 400 sine of 4 by 2. That would be, from here you can find that y would be 400 sine 2. This is going to be your answer. This is going to be your answer. So option A would be your correct answer. So have you, so any doubt in this entire session? entire session में कहीं पर भी कोई डाउट? कहीं पर भी कोई डाउट? प्लीज टेल मी, कहीं पर भी कोई डाउट? Any doubt in understanding anything? Okay, so very good. If you have understood each and everything, then it's very good, very good, very good. So tomorrow there would be a strength of material class in which the good questions will be discussed, which is relevant for GATE 2021. And then after that I would be teaching you the theories of failure. Theories of failure. Okay, so you can attend my classes at 10 a.m. tomorrow. If you have enjoyed this entire class, then do like this video as well as share this video in your friend circle. As well as if you're going for the plus subscription, my dear friend, do not forget to use my code SIRVK SIRVK to get a 10% discount, as well as I will provide a personal mentorship for you for the same. And one more thing, you can follow me here. You can definitely follow me. You can follow me there. Just a minute. So in the Unacademy app, you can follow me here at the rate of v.ksir, where tomorrow I will be teaching you the strength of material good questions, which is focused for the GATE 2021. That is what is from my side. I hope you have understood each and everything. If you have any kind of doubt, just let me know. Otherwise, I am going to end the session. If you have any kind of doubt, just let me know. Otherwise, I am going to end the session. Please let me know if you have any doubt. Okay. So I assume that each and every doubt is clear to you. So thank you so much for active participations and making this session to be very much interactive. I highly appreciate your contribution. Let's see in the next class. Till then, thank you so much.